In this problem, we're given parametric equations and asked for the magnitude of the velocity vector. Well, this is the position vector, so the velocity vector will be the derivative of x and the derivative of y. The magnitude of that will be the square root of the sum of the squares of those components of the velocity vector. And this squared gives you 4t squared, and this squared gives you 4t to the fourth. So there it is. That's the magnitude of the velocity vector. We could factor out the 4t squared in the square root sign, and the square root of 4t squared is 2t. And what would be left is the square root of 1 plus t squared. So either of these would be great. What about part B? What's the total distance the particle travels as t goes from 0 to 4 seconds? All right, well, remember that the distance formula from physics is rate times time. Now this won't do it because these positive and negative velocities will be canceling each other out, giving us displacement. But if we take the absolute value of that, then it's basically speed, and speed will be your rate. Rate times time is distance. Accumulate that from t is equals 0 to t equals 4, and we'll have the total distance traveled. And notice that this absolute value of velocity is the speed. So that's the function we'll use. You could use a calculator from this. Now, we actually can do this antiderivative pretty easily with a u substitution, but you can use a calculator. The u substitutions will be part of the second semester review. If u was 1 plus t squared, then du would be equal to 2t dt. So this would be a really nice u substitution, but if we just use our calculator, we'll get that this is approximately equal to 46.062. The units there, I don't think they gave us units in this one, so we'll just say units. All right, and that brings us to part C, the final part of number 50. What is dy dx? Well, we already know this. It would be dy dt over dx dt. Easy peasy lemon squeezy. So dy dt is just 2t squared. Dx dt is just 2t. So it's just t. That's going to be units per time unit. Might be seconds. I don't think it says. So we'll just say t. But hold the presses, hold the presses. They asked for this dy dx as a function of x, not as a function of t. So if the slope is t, what is that as a function of x? Well, x is t squared minus 3. So just solve for t. Solve for t. So t squared will equal x plus 3. So t, which is the slope, will be equal to the square root of x plus 3. All right, that concludes problem number 50 from section 11.2 packet.